All right, folks, it's Bass Action back in action. On this video, what we're going to do is talk about how to write the equation for an ellipse, both from a graph and from some characteristics. So let's start with the graph because that's going to be our easiest part. And before we even get into the graph, I just want to remind you that when we write the equation for ellipse, we know some basic things without even looking at the graph. We know we're going to have a fraction plus a fraction, and it's always going to equal 1. We know that the numerators of each of those fractions are going to be binomials squared, and we know that all ellipses will be x and then y. Now, from there, what we're going to do is we're going to come over and we're going to look at our graph, and we're going to just read the center of a -3, +3, which means we can actually answer the question down below, -3, 3, and we can even fill that in on our equation. So x minus the x coordinate, so that'll become a +3, and then y minus the y coordinate, so y minus 3. Then we're going to go back to our graph and we're going to count this horizontal distance from the center to the ellipse, and we're going to see that that's a 5. If we count the vertical distance from the center to the ellipse, we're going to find that that's a 6. We can use those two numbers because the horizontal distance squared, that 5 squared, will go under the x's, and the vertical distance squared, 36, will go under the y's. And that is your entire equation for your ellipse. Now, the other thing that we can do, just as a review, is we could find the c value, the distance from the center to the foci. Remember that equation is c squared equals a squared minus b squared. I don't really care what is a and b, but what I do know is that when I do this algebra, the a needs to be the larger value. So I'm going to do a 36 minus a 25, which gives me a c squared of 11, so the c value is a square root of 11. So I've got a couple review questions for you if you want to practice these. Make sure that you can get these answers for the vertices and the foci. But that part's just some review, just some little extra practice for you. Then down here, we're going to also write the equation for an ellipse. But this time I'm not going to give you a graph. We're going to have to build it. So let's again start with the fact that over here where it says write the equation, there are some things that we can do right off the bat. We can say fraction plus fraction equals 1. We know that these are going to be binomials squared, and we know this has to be an x and this has to be a y. So what we need is the center, the horizontal distance, and the vertical distance. So let's go ahead and make a little sketch. Let's look at the information that's been given to us. It gave us that the foci were at 2, 5, and 2, -1. So what's going to first jump out to me is that the x coordinates are staying the same. And when it's saying the length of the major axis is 20, we're going to use the foci, the orientation of the foci, to help us understand what direction this major axis is. So let's go ahead and make a quick little graph in case you haven't already pictured it in your mind. Since the x coordinates are staying the same, I'm going to go over 2 and up 5. So I'm going to label this as 2, 5. And I'm going to go over 2 and I'm going to go up 1. So this is the point 2, 1. Remember, it doesn't have to be to scale, but what we're wanting to know is that this is a foci and this is a foci, which means that since these are oriented vertically, this major axis is also vertical. If this is the length of the major axis, then that means that I'm actually going to go 10 from the center. Okay, so I'm going to go 10 in each direction vertically from the center. So if I square that 10, I know right away that that 10, that 100, will need to go underneath the y's because this has been oriented vertically, so this has to be oriented vertically, so this has to be the vertical distance. Okay? Now, the next thing that we're going to do is we're going to actually find the center. From this information right now, I can already tell you that the x coordinate of the center has to be 2, okay, because the center has to be along this line. So I can fill that into my equation as well. I do still need the y coordinate, so I can get that y coordinate because I know that it's going to be halfway between those two foci. So I'm going to look at these two y coordinates, And you can either count them, but algebraically what we're doing is we're finding their midpoint, so we're averaging them. So my 5 plus 1 is my 6 over 2 is going to give me a nice 3. I now know that this center is at the point 2, 3. So I can finish filling in my center. Then the last thing that I'm going to do is I need to know what is this horizontal distance. What I do know for sure is that whatever value goes here has to be smaller than that 100 because this is supposed to be stretched vertically. So it's a good little just self-check. Now, to find that value, we're going to use the C value, the distance from the center to the foci. Remember, that equation is C squared equals A squared minus B squared. And our C is going to be the distance from the center to the foci. So the distance from my center to my foci is 2. So that's going to be my C value. So I'm going to come down here and I'm going to square it. So I have 4. Remember, A squared is always going to be the larger of the 2. So that's going to be my 100 minus my B squared. I'm going to rearrange this and say B squared equals 96. And that's automatically going to go right there. So then we are all done writing the equation for ellipses.